So, good morning. Thank you all for being here. I do not have a paper. I did not write a paper, unless you consider something this small to be a paper. But I have a lot of thoughts that I'd like to share. Please excuse any sort of fragmentary or aphoristic elements in my talk. This is meant to be a start of a longer discussion rather than anything fast. How do you say that in English? I forgot, even though it's my mother tongue. Nonetheless, as many of you may know already, I am a pianist. And I've been a pianist for a very long time, since I was 7 years old. So I've come over the course of my life so far to really love the piano. I love it. It's my instrument. Of course, however, in contemporary music, this is slightly problematic. The piano, in general, the piano is sort of feared today among composers. The sound of the piano, the sound of its intervals, the sound of its temperament are often considered either too connotated to be used in an untreated way, so to say. I'll get to that word treated in a bit. And so many different ways of trying to use the piano in a new way have come about. Of course, since the 30s or 40s, prepared piano has become huge, and it's more often that we hear prepared piano in ensemble pieces now than we hear normal playing on the keys. Playing on the inside is very popular. The detuning, and of course, trying to find new pianos. So, for example, this E piano here. In fact, this fear of the piano is so prevalent that you talk to students of composition here and in other places, and they all say, writing a piano piece is the most difficult thing. I can't imagine writing a solo piano piece. How do you write so many solo piano pieces? I hear this all the time. And I mean, it's quite easy, just write pitches. And I think one thing that's quite interesting about all this group of people here is that we're all here because we're quite obsessed with the phenomenon of pitch combinations. What happens when two different frequencies hit each other in a room. I think this is of course, a simple phenomenon, but it's magic. As Morton Feldman would say, pitch is a magical phenomenon. Before I move on, I'd like to talk a bit about the piano in a sort of deconstructed way, to use a word that I hate. The piano has a very, very, very recognizable sound, as we all know. It's also incredibly difficult to imitate, as perhaps the pieces for the E piano that were the solo pieces for E piano that we heard yesterday were demonstrative of. The piano's attack, its decay, its resonance, and the use of the pedals are all so fine and so create such small differences in the room that it's nearly impossible to really recreate it, even on great systems or great synthesizers, etc. It's very, very difficult. Even great electronic pianists, for example, cannot make sympathetic vibrations happen. It's just impossible without real strings. So, that leads me to the conclusion when often I wind up playing this kind of pieces for microtonal E piano, etc. And I always have to come to the conclusion that this is not a piano. This is just a completely different animal. It's a different instrument. It's more akin to a synthesizer. But of course that doesn't make it any worse. It's just different. One thing I, however, noticed yesterday was that the combination of this, I was talking with Alyssa about this, of the e-piano with piano, actually created a pretty interesting sound. I don't know how everyone else felt, but I think it works quite nice, because then the pressure of this imitating the piano was then not there, and the differences were then brought to light. So what then, as a composer, should I do? If I'm interested in microtonality, if I'm interested in, but yet I still love the piano and I don't necessarily feel the need to change its temperament or mess with it in any sort of way, to use a vague term. And for me, the real important word that I've come upon is just recontextualization. How do we recontextualize the sound of the piano so it does not have this overly connotated sound? And so I think I would like to show a bit of, the score of the piece that was played yesterday, because in that piece I tried this in order to create sort of a fused timbre between the organ and the piano, and between the two different temperaments of mean tone and equal temperament. And then I'd like to show also, if there's time, a little bit of a piece for violin and piano where I also try to do that. As we all know, the piece from yesterday, without recording, it's quite difficult to really talk about. Here's the first page. I'm sure we all were looking at the table of tunings of the different pitches for the Frescobaldi obsessively over the last 2 months, probably, when we were writing our respective pieces. And so you all know the difference or the small micro intervals created then if equal temperament and mean tone then are sort of overlaid upon one another. And so that's just what I wanted to focus on in this piece, and that's why I've started with C sharp, for example, instead of a key where they line up perfectly, just to already start with the beating. If anyone wants to look at the score later, I can just send it to you free of charge. Good, I'd like some laughs, that's nice. That's also how it looks when it's small. And then we can listen to a bit of this poem for violin and piano. I can show you a bit of the score first. I think it's nicer that way. Why is it showing this way? 2 pages. See here I'm using 11 limit in the violin and combining it with the piano. In the recording we will hear, it's a live recording from the premiere of the concert, so the intonations aren't perfect. It's also hard to do, but I think in certain parts it really worked quite well. Let's listen to a bit of that. Maybe what time is it? First couple minutes maybe. If we can hear it. course, this goes on. I could have picked, of course, excerpts with a bit more of the microtonal exploration, but you heard the beginning. I can send you this score as well if you want to have a deeper listen at some point. Another thing I wanted to touch on earlier, but I was a little bit too nervous to remember, was that, of course, how do we recontextualize the sound of the piano then? Of course, through interaction with tones that don't fit into the temperament of the piano, of course, throws the whole sort of equal temperament system that we're so accustomed to hearing askew, and we are able to hear it with new ears. Another way, of course, is just simply through time, through repetition. We're able to hear something. It's similar to looking at the same word over and over again. We start to lose its connotations and contexts linguistically and start to just see the shapes on the page. And I think that kind of perceptual phenomenon is something that interests me a lot, musically. So, yeah, I think that's enough. I mean, we're already a bit behind schedule, so I'm just going to open it up to questions. I was thinking about playing a little bit of an opening of a Schubert piece to recontextualize for all of you, equal temperament a little bit as well, if there's not too many questions. But let's start with questions.
Yeah, just something I noticed in this piece and also yesterday's piece, but I really like kind of, it clicked for me not seeing the score and hearing it. Something I really like about both these pieces is it feels like the two tunings are really, and the two instruments really are functioning on very independent layers, which then, I guess with time and with repetition, like kind of coalesce into these, really beautiful beatings and stuff. And I feel like I haven't really heard just intonation intervals like treated in this way. Because I feel like usually like when we're writing in JI, we like tend to like try to create like harmonic fusion and like these kind of unique effects. But this felt much more like almost like a Martin Feldman type thing, where it's like these like free atonal things which are using these beautiful
Right.
sounds. And I'm just wondering if you have any. Do you think about this like interaction of separate layers in any kind of way?
I definitely do. I think that's you actually hit the nail on the head. I like, for example, I mean, I think in new music, there's quite a lot of tradition of trying to make things fuse and become one constantly. For example, yeah, I mean, if just for a quick reference, if you talk to composers that have a tradition in France, for example, or they really want some sort of fusion where you don't hear the individual identities of the instruments. For me, it's much more interesting actually hearing the two instruments as two beings. And then later, it becomes more fused just through the temporal process of looking at the whole plane.
Do you have like an approach to the pitch language to like kind of keep to maintain that separation?
Absolutely. I mean, I can show you a bit. I mean, so this entire piece is actually, I mean, the harmony is actually just derived from the open strings of the violin, and just sort of, if you flip them into prime form, and then it becomes two major seconds, right? And just so this, there's a major second structure just sort of constantly pulling apart in this piece, and it happens 6 times, and the piece itself is a sort of palindromic structure. But what that gives me is also the ability to create sort of tuning implications. So for example, I think there's a really great part here that you can understand what I mean by that. So I try to treat it melodically, in this part at least, but you see I have the septimal of the B spectrum here against what the piano would approximate parts of the B spectrum as So to create this
Your ear gets pulled into
exactly pulled into a direction, but of course still having a bit of crunch from the just approximation. Of course, the third is too high, and the 13th there is not even close. And then through this, and then through this sort of contrapuntal play, I'm able then to also switch between different spectra. If that, I mean, but of course it's not perceptible really. It's just giving a different harmonic color. And I mean, I think this is one of the traps that JI often falls into, is that it falls into the trap of seeking some sort of harmonious purity, which is, I think, a bit of a dangerous sort of ideological trap, frankly. But for me, what's the most interesting is that it unlocks a lot of new intervallic colors that can be combined with any other interval. And I don't think any interval is particularly privileged in this sense, but I think it's just more colors for us to use. Go ahead.
I really love the Gradualness, especially like a purpose detail, but in a used and elitist way of holding, I would say.
Sure.
Yeah. And I just have some really small questions.
Yeah.
I really appreciate the development, especially for the supont. I think no possible, but supont and harmonics.
Yeah.
Is there any specific reason that you want to use these at these specific points, like for the spectrum or just for the variety?
Now, for me, this is a melodic detail, I think. Why I have it here.
The ponticellos, the harmonics.
That's maybe I'll try to avoid this question by saying that's for me to know and you to find out. No, I mean, you know, I don't have a particular formal reason. I mean, of course, this piece is quite strict formally, but in terms of the surface level there, I'm just trying to make a beautiful surface.
Okay, that
Yeah.
works.
Yeah.
I think also the use of very close voicings throughout also is helpful to sort of negate the discrepancy between the equal temperament and accentuation.
Yeah.
I think if it was more broad, I
Yeah.
think that you would hear that discrepancy more. And it's really nice how when there's more melodic material kind of pulls away from this very small register a little bit, like the harmonics and these couple piano notes you have in fifth octave.
Yeah.
It kind of becomes more I don't know, specialized.
Yeah, thanks. Yeah, I mean, I actually just lost my train of thought as I said, yeah, I mean, yeah, actually, when I was writing this piece, I think it was the piece I struggled with the most in the last years. Of course, violin and piano also is sort of one of these notoriously feared instrumentations because historical connotation, etc. But a lot of my music, I mean, as you could hear yesterday, there's a lot of thick chords in a lot of the things I write. And that was sort of the original starting point for this piece, and it just didn't work. And I kept throwing away drafts and throwing away drafts and throwing away drafts, and then I just tried, paring it down. And then it seemed to work, finally, after months. Yeah. Do we have some time for something quick, just for some fun, or should I end? I should end, I guess. Okay, later in a break. In a break. Yeah, we'll have some extra fun in a break. Great. If there's no more questions, thanks everybody. And up next.
So thank you a lot, guys, for having me here. I will give a general context about this project I developed. So first off, let's speak about consonants. So traditionally in ancient Greece, consonants were coming. So we can say Pythagoras, like he's one of the founding father of this consonants ID. So in his views and in the views of most traditional Greek theorists, consonants arise from simple ratios. So like you take whatever pitch root note you want, and there is like this formula that apparently they found quite fascinating, which is n plus 1 over n. So for example, 2 over 1, you know that it gives the octave. So they treated like, so the octave, as it's one of the simple ratio, is considered like the first most consonant note in the old Greek treaties. Then, if you go one step further, you have a 3 over 2, which is the pure fifth, and it's considered like the second most consonant interval, and so on and so forth. So, yes, the ancient Greek really had like these 3 main consonants. So octave, then 3 over 2 is fifth, and 4 over 3 is the fourth, as you know. So, and it has been considered like those 3 main ratios has been considered like the founding, basis of consonants during centuries. And of course, so I'm really generalizing because like, of course, there has been some development in the time, but the main idea stays the same. So we have the octave as the main consonants, and then fifth and fourth. But then arrived like, more scientific modern way. It has nothing to do with the consonants at first, but you will see it will have some link. So Sauver was like the founding father of acoustics, and he began to analyze sound in terms of timbre, vibration, and harmonics. And Helmholtz even go further with this idea. And Helmholtz realized actually those old Greek ratios and European ratios, I could say, actually is linked to the natural harmonics, you know. So if you analyze a sound and you break it apart from its components, you can find in an idealized setting, you will find some part of the, so you play a root note on a string, for example, piano string, and you can have you can have the how to say that? If you do like a FFT analysis, you would find like there is the octave, then the tritave, which we say like the third multiple of the root note, and so on and so forth. And Helmholtz realized actually, if you think back to these Greek ratios, so it's the same actually. So the relation between the octave you find in an instrument timbre, it's the same as was saying Pythagoras or other music theorists, is the 2 over 1. And for the fifth, so it's not the second component generally you can find in timbre. So it's 3 times the root. But if you look at the relation between the octave and this third harmonic, you find back this 3 over 2, which is defining the pure fifth. And you can keep on like that. And 1 century later, there has been a paper, I had in the room, sorry to put the name of the paper, written by Plomb and Levelt, and they worked on psychoacoustics, and they realized, okay, so if there is a link between those natural harmonics, idealized harmonics, and some consonants, maybe it means if there are other possible timbres which are not following the natural harmonics, maybe there is other consonants that can be how to say, that can be well, I don't have my words. So if you don't have a natural spectrum, it means maybe other ratios could be a consonance point. And, I hope it makes sense. And but they didn't expand it a lot. So in their paper, they just suggested maybe an enharmonic spectrum could have other type of consonants than the pure intonation, just intonation ones. And that's where William Setares wanted really to explore this concept, and he began to do some experiments musically, and also wrote some articles. And finally, he summed up his discoveries in his book, Tuning Timbre Spectrum Scale, which you can find actually, the author was kind enough to put it for free on the internet, so you can look it up. And yeah, this book, I must say, when I first read it, it was really, it's really changing your perspective about the relation between scales and timbres. And so he first begins to analyze enharmonic spectrums, and by some really complicated computation, which I'm not going into because I haven't the background necessary. But in short, he takes a timbre, for example, he's writing in his book, like he was fascinating because when he was doing some walks outside, in his region there had been some rocks which has a strange resonance. So he recorded these rocks and wanted to see if he could construct a scale, so like sampling the sound of the rocks, which has not an harmonic spectrum, and see if he can derive a scale. So, and he does that by using this concept of roughness curves, which comes from psychoacoustics, and he pushed this idea really far and realized, for example, he spent some time analyzing. So I think everybody knows gamelan music from Indonesia, which is famously out of tune in a Western perspective. And he realized by analyzing the resonance of the traditional metallophones you can find in Indonesia, that those they don't have a proper harmonic spectrum. They have a spectrum which is not following the natural series, but the points you can derive from this spectrum, from the roughness curve, I mean. So yeah, I should have included a picture, but a roughness curve, sorry with the word, is like you. I don't know if you are familiar with this concept actually. The roughness. Okay, so you take two notes and you ask people like, do they feel dissonant or consonant? And you will see like something like that, so a curve that is going up, because at first you are like in the half step region, which sound pretty rough. You can feel a lot of beatings, and then there is some how to say, some holes in the curve, which corresponds to more perceived consonant ones. And when you apply that to the lamellophones from Indonesia, you can find that the local minima of these curves correspond roughly speaking, to the notes you can find in gamelan. So it's pretty interesting, I think, to look at this way, that these scales also arise from the way these instruments sound and how their timbre is physically happening. And also in his book, he proposed, why not doing the opposite, you know? So you start with a tuning system, an arbitrary one, and then you derive a timbre. And that will be the focus of this project I've developed. But yeah, just for information, so it's my personal interpretation, because as I will mention at the end, he's using more advanced algorithm that I do. So, it's the green, no? Oh, perfect. So, I invite you to, let's focus about two tunings which are famously, how to say, give dissonance. So, for example, the 11 division of the octave, which apart from the octave and some good third, has like a rough. When I say rough, it's another way to say dissonant, because dissonant, you know, is culturally constructed, and rough would be more like a mathematical, scientific way to define that. So, for example, if we take the 11 division of the octave, we can see the fifth is around 655 cents, which is like halfway between the tritone and the pure fifth. So it sounds like to Western ears at least, it sounds a bit like out of tune, like a bit unsettling. And the other example is I will focus on is 13N3. I don't know if you are familiar with this notation, but so it means a division of the tritave. So the third harmonic, we could say, which is also known as the tempered version of Ball and Pierce. And this tuning, if you analyze a bit the intervals, it has an octave which is a bit low, you know, compared to the pure octave. So it's around 1,100. Is it 100? 100, 1,000?
Yeah.
Okay, yeah, but it's written, so. And so it's 30 cents below, so it will sound if you play, I will play them for you. But and also it has a fifth which is a bit higher than the pure intonation, so like supposedly this Ball and Pierce scale shouldn't, so it wasn't the purpose of the scale to make those intervals sound good, but when you look at those numbers, you're like, okay, it's maybe a bit hard to create stable harmonies, you know, because the fifth and octave are pretty much important in a Western perspective. So this is 11 division of the octave. So I will play this quote-unquote fifth, and we are using a sine wave first, so that we really have an idea of the interval, how it sounds without the spectrum, without having influence from the spectrum. So if I play them, it really feels, at least to my ears, it sounds really more like tritone than a proper fifth. But I mean, when I say that, of course, maybe you like the aesthetic of this chord, but it doesn't feel like a stable point to harmonize. And the fourth also is a bit out of tune, like. And then, if we go to the Ball and Pierce example, you can hear this low octave, which has really this sound like you feel it's not really right, you know. And the fifth also is like, yeah, you feel it's a bit higher than it should be. So yeah, but it's only a sine wave, so we don't really have. Of course, it's not a pure sine wave because of the digital computing, but it has almost no spectral component. Now, if we switch to the square wave and listen to those intervals again, it feels, I think, to my ears at least, this tritone is even more like, you can feel there is some clashes because a square wave is really following the natural series. I think it's the even harmonics. So if you begin to construct a chord, it gives even more like dissonance feeling. And with Ball and Pierce, this octave really sounds rougher. And if I stack a second one, there is something like you've heard it, like it's like compared to the sine wave. Oh, sorry, I messed up. With a sine wave, you could manage it, but with a square wave, it's really like. So okay. Oh, I forgot. So The idea is now, can we construct a spectrum that would be more, how to say it, that will allow it to sound more in tune. So the idea of my algorithm, so I'm not using a roughness curve, but the idea is like, let's start from the tuning, and by using some integer multipliers, let's try to find, to look for multiples of the tuning steps which approximate, quote unquote, the natural harmonics in a range of plus or minus 50 cents. And firstly, to achieve that, we take one of a natural harmonic divided by the step value. And so we find a ratio between the step value of the tuning and the harmonic, and we look by using the floor and sail function if it matches this plus or minus 50 cents range. So, for example, if let's say the first harmonics, which is the octave, divided by the first step, yeah, the octave is not a good example actually. Let's say the third harmonic, and if we have like a ratio of 2.34, we will look to 2 times the specific step, or 3 of the specific step. So I mean 2 times and 3 times, and we will see the algorithm will check whether it's in this plus minus 50 range, and if not, it's discarded. So maybe some tunings haven't a good approximation of some harmonics, so we don't take them into account. And at the end, we use all what the algorithm found, and we feed it in what I call a sine bank. So it's like a sine bank, I don't know, like many sine waves that will really use those ratios. So, oh, sorry. And okay. Let's. Huh. Okay. So here is the result. I don't know why on the line where ratios is written, I don't know why it doesn't, but probably it's a max stuff. Sorry, I had to switch. So now we can listen to what the algorithm found. Oops, sorry. I'm changing a bit. So the idea is like, once all these ratios has been found, we can change their amplitudes so that we have a variation in timbre. So this is the 11 division of the octave example, but with those retuned harmonic. Let me find a good... and we can compare with the natural ones. There is something wrong, and I'm sorry about that. Anyway, I'm sorry, like there is apparently something hasn't been...
The sample rate is...
No, it's about, I don't know, I think the ratios...
triggering?
Yeah. Because it should I'm just sorry, it's a few minutes because it's changing. I'm sorry, I don't have time to to
Is
check.
it accessing the libraries accurate, right?
Yeah, I think so, but my fear is like the library has changed.
Oh, okay.
Mm.
Because we just downloaded it right now.
Can I maybe from my laptop and without the plugin it?
Maybe what we can do is we can do questions now, and then at the end of the
Yeah,
session,
sure,
since
sure.
it's a lunch break, you can open and people can listen.
Yeah, maybe I'm sorry for the yeah.
And I think we can also share things after the fact. We'll collect
Yeah,
them
sure.
and share them.
So if I'm just doing the conclusion, but sorry, the demonstration is not. I will show you after. But I just wanted to finish that. So the advantage of this algorithm is like it's a fast algorithm. We could imagine to use it dynamically, so you could change the tuning and the timbre will change with it. And also one of the advantages, like we are really like preserving kind of a natural harmonics setting. But of course, so I'm not using roughness curves, and also so the amplitudes of the harmonics have an impact on the perceived dissonance. So, and I'm not using amplitudes in my setup because the amplitudes are randomly generated. So, ZRS propose an algorithm which takes into account the possible partials you construct. And also, the last thing is like the relation between those approximations is not taking into account the relation between different harmonics. So, for example, let's say the octave is approximated by some values and the tritave by another one. Which my algorithm should check also if between them the relation is preserved. I don't know if it makes sense. So, for example, if there is a lower harmonic for the octave, the tritave should be lower also, maybe to preserve the relation. And that's something I want to implement. Okay. And yes, in the future, I would like to really try what ZRS propose, like using, for example, genetic algorithm, because they can allow to this kind of really complex problems. And when you want to find local minimas in a multi-dimensional problem, genetic algorithm could be a good candidate. Okay, thank you.
I'll start. Hi, good day. My name is Sergey Kim. I'm a composer, musician, and yeah, today's topic is about the early Russian experiments, and particularly about Odoyevsky 19-tone enharmonic Klavitsin. So when we are talking about this enharmonic keyboards or microtonality in Russian music specifically, mostly think about composers. Maybe composer, as Ivan Vishnegradsky, but apparently there were plenty of composers at the beginning of the 20th century. Apart of Vishnegradsky, there was like Mashutin, Avramov, and other composers. Actually, also Grigory Rimsky-Korsakov, who is the nephew of Rimsky-Korsakov, and he organized the first in Russia the Microtonal Society and Ensemble. They played in the 20s, and then they would shut down during the Bolsheviks. But actually, it started even earlier. In the beginning, in the middle of 19th century. And but before, I would like to shortly discuss about the enharmonic keyboards, just to remind you, because it has some parallels between this historic approach. And so that's starting from the late Renaissance and specifically during the early Baroque era. The split keyboards, it was the kind of normal practice because starting from the one split key, it's like 14, 15 keys per octave, and it was done like because there was plenty of problems. It was done because there was a mean-tone temperament, and it was not a cycle. It was like it was spiral and it not closed system, and they had problems like a wolf fifth between the, you can see G sharp and E flat, and which caused many problems. There was specifically tonality which you can compose the pieces like mainly not more than 3 flats and 3 sharps. And also these split keys, they allowed composers and musicians to expand the range of the usable tonalities. For example, now you could play the A flat and E flat, and also to be closer to pure intervals, which some composers were very obsessed. And also experiments with enharmonic genus. There are numerous variations of enharmonic keyboards around this era that may incorporate, for example, 13 keys per octave. You can see this problematic E flat G sharp was split. And then there was like 14 keys per octave. Now it's the 2 splitted keys like G sharp, A flat, D sharp, E flat in Italy. The 15 keys per octave and much more. For example, this is a sketch from the Marine Mersenne treatise. It's not built, but it was a concept. But perhaps the most famous one is example is Nicolas Vicentino's Archicembalo and Archiorgano, which has 36 keys per octave. And the 19-tone keyboard is one of the most common. There are many examples of instruments, like starting from the Zarlino's time, from his treatise Instituzioni Harmoniche from 1558, then the Spanish composer Francisco de Salinas from De Musica Libri Septem, then Carlos Newton, Michael Pretoris was describing lots of those unusual keyboards, including Carlos Newton and other composers. So the 19-key keyboard was a perfect solution, practical balance between the tonal flexibility and structural simplicity, enabling performers and composers to play and write in all tonalities now, even the far tonalities, without the Wolf issues. And here you can see the layouts of the, for example, Il Cembalo Cromatico from the Italian version, or also Carlos Luteon. You can see this, for example, this mouse is not here, but yeah, C sharp and E flat. So D sharp, it's even in the third row, C sharp in the second row, so it's not even. Furthermore, it's tuning typically in the mean-tone temperaments, provided the relatively pure intervals. It's a more common 4-comma mean-tone, but also like there was 19-tone keyboard from the Salinas, which was a 1/3 comma mean-tone temperament. And Odoyevsky and Enharmonic Klavitsin was it's unique because of it's tuned not in the mean-tone temperament. It's not a temperament system. It's just intonation. I will talk about this later, but first I will introduce him as a person. The purpose why he built this, because he wanted to perform the Russian folk songs and also Orthodox chant, which cannot be played on the temperament tuning system. So, who is Vladimir Odoyevsky? He is I think, one of the most important thinker, philosopher, writer in the Russian history of 19th century. And he's the first Russian music critic. He's a knyaz. Knyaz in Russian is the kind of noble title. It's both for the royalty and also for the noblemen, aristocrats. So, being a wealthy man, he had a huge collection of books, also, as well as musical instruments. He commissioned plenty of musical instruments. And one of his first unusual instruments that he commissioned, it was a house organ that he commissioned from the German master, Georg in St. Petersburg when he was living there. And this instrument he named Sebastianon, after his favorite composer, Bach, Johann Sebastian Bach. And this instrument had a distinct feature. It is possible to play crescendo and diminuendo by pressing the key harder or weaker. Unfortunately, this instrument is not so right, but you can see in the background, it's called Sebastianon in this picture. He's also known as one of the first musicians who started to collect the folk songs, and it was during this one of these moments at the end of the 40s when he realized that the temperament tuning of the piano could not reproduce the detail of folk songs. And later on, he moved from folk songs to study the old Russian church music, and he also realized that even here, it's not suitable for equal temperament because you know the also Orthodox chants like known as Znamene Raspev, it's based on the Byzantine music. It's not only Russian, but also these Eastern Slavic countries, including like Ukraine, Belarus, but also in Serbia and Bulgaria, and these areas. And actually, this is a quotation of him. He wrote in that I recorded a very interesting song from the voice of our famous singer Ivan Estrafovich Molchanov, a man with a wonderful sense of music. In the second measure, I noticed that the singer's B, the pitch B, didn't fit in any way with my piano's B. And Molchanov's, the singer, noticed also that there was something wrong. I repeated this motif carefully, trying to reproduce the singer's note, and it turned out that my voice didn't match my piano's B either. And in the late 50s and 60s, he started to research these tuning systems, studying many theoretical works but the most important for him it was the works from the Gaspar de Prony, Karl Gottfried Wilhelm Vollmer, which is known as the Zimmermann pseudonym, and Starlinus treatises, among others. He also wrote his own books and articles on this subject. Among them you can see the notes on acoustics, the formation of intervals, an attempt to harmonize and arrange Russian folk songs, Greek notes from the perspective of acoustic logarithms when he tried to measure them with the Prony's methods using logarithms. Then music grammar or the music basis for non-musicians. And it was in this treatise when he composed maybe his own approach for the tuning systems. And everything, all this indicates that at the time Odoyevsky was working, trying to realize the regularities of Russian folk music and to bring them into some kind of coherent theoretical concept. These articles, he states the diatonic genus in Russian music represents the following ratio. So you can see it like 1 over 1, 8 over 9 over 8, 5 over 2, etc., like a kind of C major scale. And you probably notice that it's just intonation. It's based on the 5 limits. It has pure third. It has perfect fifth, and actually it's very close. It's almost the same scale as the Indian Bilaval rag, which has the same ratios in the Hindustani music. And it's Odoyevsky also noticed this, and he wrote this that in Russian music is closer in its basis to Eastern music than to Western music. And he wrote that some Indian notes sound the same as our echoes. Echoes is the system of the Byzantius 8 echoes, like 8 notes. This was based also on the Slavic Church, Orthodox Church. And these observations led him to reject the principle of the temperaments and to declare that it's contrary to the laws of the nature. He also, there was one quotation, that he was telling that if the singer of the folk songs is, if you're thinking that he is singing out of tune, it's not because he's singing out, it's because your ears are spoiled by the temperaments. Yes, so in the 1864 he commissioned a new instrument. This time it was an enharmonic keyboard, which he called enharmonic Klavitsin. Klavitsin is in Russian, it's a clavichord, and it's old Russian Klavitsin, but nowadays it's Klavitsin. But in reality, it was the piano with hammer action. It was not the harpsichord. Probably it was in the order of the old treatises like Salina and others. And the piano was constructed at the Moscow factory of the German piano builder August Campe, according to Odoyevsky's own sketches. And I think it's obvious. It's a small size grand piano with 83 keys in total, covering 4.5 octave from lower C and the upper F keys. And the keyboard layouts consist of 3 rows in the following order. So in the first order you have like normal diatonic scale, C, D, F, G, A, B. The second row it has 5 black keys representing the C sharp, D sharp, F, G, and A sharps. And the third row, it represents the same diatonic scale but in the flat, except the E and B. If you noticed, it has this almost the same layout as the Carlos Luton's or the Tsarino's layout. The only with difference that D sharp and E flat and A flat, B flat, it was changed the position. Yeah. So the 19-tone scale is tuned not in temperament, as I said, it's based on the 5-line gesture intonation. And as a basis, he took the ratio of 25/24, which is the and its inversion is called as decode comma, or more common is the just chromatic semitone, which is approximately 70 cents in size. And in his system, he bases the basis of the scales. So he took the 7 step of diatonic scale, and he multiplied by 25/24 to rise up, and divided to flatten each step. So in his table, you can see, for example, what he's doing. He took the seven keys, multiplied by 25/24. You have like 7 sharps, and then make the 7 the same but flattered. So 3 times 7, 21. But he didn't apply the F flat and C flat, for the reason that it was too much wolf intervals. So you can see like C sharp 25/24, then D flat 27/25, then D natural 9/8, etc., etc. As a result, we have the following table. So you can see it is very narrow. The narrowest interval is 41 cents between the D sharp and E flat, for example. It has like 4 intervals like this. Then we have one interval with 62 cents, with 63 cents too, and plenty of 71 cents and 70 cents. This is the tuning lattice. If you can see here, it has 13 pure thirds. If you look at the vertical lines, in the horizontal lines, they have 13 pure fifths, and also wolf fifths. If you can see the diagonal line from the upper A flat to the A sharp to the D sharp, for example. That's 75/64 to 125/72, and the other 4 wolf fifths. All of the wolves, they have the same interval size, which is 680 cents each. This is the comparison between the equal temperaments, his 19-tone scale temperaments, then 1/3 common mean-tone temperaments proposed by the Francisco de Salinas in his treatise, and which he was using, and quarter common mean-tone temperament with the 19 steps per octave. So you can see, for example, in this comparison, the E, the major pure third, is the same as the quarter common mean-tone, but the fifth, the perfect fifth, is the pure interval, and yeah, some intervals they match. For example, with the 1/3 common mean-tone temperament, the minor third is also pure, as they have the same as the Odoyevsky. Also the other intervals like F sharp. Later on in 1869, after his death, his wife Olga donated his musical archive, including Enharmonic Klavitsin, to the Moscow Conservatory. And unfortunately, in the next 40 years, his archive was gathering dust somewhere in the basements. Nobody was carrying it at all. And only after the opening the Nikolai Rubinstein Museum at the Moscow Conservatory, all his musical archives was transferred to the museum. And but an Enharmonic keyboard was transferred to another museum, the Russian Museum of Music in Moscow. he was a composer. Well, you can, if you read his biography, you can you read that he was the amateur composer, like not professional. But what is professional composer? You know, because he was studying music since he was little as a nobleman, and he was the organ player. He was a pianist, and he composed not many, like few pieces, including some pieces for his Enharmonic Klavitsin. And the last piece that he composed before he died, it was the piece which he called Verbotene Quinten, which Forbidden Fifth. And this piece was dedicated, based on the main the cadenza of from the Johann Sebastian Bach choral, Ach wie flüchtig, ach wie nichtig. So in this cadenza he was probably amazed by the parallel fifth that he is using. You can see like D and A, then C and G. Yes, this piece is a short piece. It's like 2.5 minutes. It has only 27 bars, and we will listen to this. But first, as a reference, I will put the Bach's cadenza, just a few seconds. And now his piece Verbotene Quinten. To finish this presentation, I wanted to focus on this picture because, you know, don't disappear. Yes, this picture. You can see this piano, which reminds you of this enharmonic keyboard. But the mysterious thing that this picture was made 20 years before he commissioned the piano. So in 1840, and which led to some questions. which is, did he have the second piano before, or maybe if yes, where did it go? Because it might be, of course, some errors from the painter, which is not likely. But this is the open question, which needs some investigation, I think. And the piano today is in the Russian National Museum, not in a good condition because it was not played, not used for the more than 100 years. And yeah, this is the open question of this. Thank you.